Just a couple of announcements. I don't think any of them are all that crucial, but just to let you know. Well, they may be. Depends on where you are. First, I'll sit down. I need to stand up so I will record. This afternoon, there is a faculty meeting at 2:30. But the vice president said if you got class, continue classes. So there shouldn't be any interruption in classes. But in case you do have an afternoon class, you might want to check with the instructor, check email, Blackboard, or whatever, to make sure that your class is meeting. Because some people have to be at that meeting. I'm going to be there the first part, but I've got a class that starts at 3:15, so I'll be leaving shortly after 3. All right. Tomorrow, normally I have office hours on the Birmingham West Campus. We're supposed to be out of town, so I would put in for personal leave. But if I don't feel any better than I did this morning, I'm not going to be on campus tomorrow. So either way, I'm not going to be on campus tomorrow. Okay? I've got to put my eyes back on. Cammy's here. And Richard, right? Okay. So, I will not be on the Birmingham campus tomorrow from 8 to 12 like I normally am. Now, are any of you in the process or thinking of applying to a university or college here in Alabama for the fall or even summer? Did you know that this week is free application week for many of the schools? Not all of them, but many of them. So if you get your application in this week, there's no fee. Now, that's not all the schools, but a whole bunch of them. I have a list down in the classroom 255. But guess what, folks? You all got the email, okay? I got the same email you did. So check your emails and check that out. Some of the schools, like Jacksonville State, I noticed theirs goes through Friday, tomorrow. Alabama, UA, Tuscaloosa, theirs go through midnight Sunday night. They do a full week from Monday through Sunday. Other schools do Monday through Friday. So check it out and see, but it's a free thing. Now guess what? 2-year community colleges, free all the time, okay? No special week involved. You know that because you're already here. But if you know people, friends, relatives, community members, church members, anyone, think about going to school, high school seniors, let them know this week is the week to get that application in for free for many of the schools. This is only state of Alabama, and it's not all the schools in Alabama, but they are doing that at this time. I can't remember if there are any other major, there are. Sort of a good news, bad news situation. The bad news is the college is going to be closed Monday. Veterans Day is a holiday, state holiday, so the college will be closed. But the good news is it doesn't affect us any. We meet on Tuesday, Thursday, so we'll have classes normal. So you can get over that. All right. And I think I announced this before, but just in case you missed it or I didn't do it in this class. Next week, I know Tuesday, I'm guessing Wednesday, maybe Thursday, there will be a team of professionals from anywhere in the Southeast, probably all over in the Southeast, on campus. That will be our once a decade, hopefully, SACS accreditation visit. SACS is Southern Association of Colleges and Schools, and they are our they are our accrediting agency. They're the ones, I cough and put the thing up so I won't get 6. Sorry, I'm just kidding. I know, it's not a bad idea. It's just funny. I coughed and it went up. Never mind. Okay. They're our accrediting agency, and once a decade they come. Now, the reason I say from all over the Southeast, all schools send people to be these professionals at those schools. None from the state of the school that's being accredited. None from that state are on the team. They're all from other states. So that's why I say they could be coming from anywhere in the Southeast. They'll be mostly, I think, on the Birmingham campus. Okay, that's where all the honchos live, and that's where most of the paperwork is and everything else. But don't be surprised to see some of them here. So if you see some honcho-looking people wandering around, they look like they might be lost trying to get out of the A building and not knowing how the numbering works, be kind to them, okay? If we pass, which all the hard work's been done, all the heavy lifting's already been done, all the paperwork, we've been working on it for more than a year, probably well more than a year, but it's all in hand, but they have to come and see that everything we said we were doing, we are actually doing. So if you see people, and if you've noticed the smell of fresh paint, that's it. Oh no, they were just happened to be painting this week. Okay. Yeah, right. Okay. Huh? I thought. Oh, really? Yeah, libraries are one place they will come. I bet they'll come to this library. So, so what are they doing? The floors, you say? Okay. Surprised how that works. Okay. Who knows? Maybe even the restrooms will get clean. No, I didn't say that. Okay. Okay. Yeah. All right. So, any questions before we get started today? Again, I apologize for my throat. It was Tuesday after this class. My next class, just in the middle of class, my throat started hurting like crazy, and it's just gone downhill ever since. So, tomorrow I'll either be out of town or in bed, one or the other. Maybe out of town in bed. I don't know, but we'll see. All right. Now, no questions. Okay, where we left off last time, what we're trying to do desperately is find zeros of polynomials, especially higher order polynomials that are harder to find, okay? We've got one of the best tools possible in our belts right now, the rational zeros test. But if you remember, the rational zeros test is the ratio of all the factors of the constant term over all the factors of the leading coefficient. Okay? Now, if, and when you do all those factors, it's plus or minus, plus or minus, plus or minus, plus or minus. And remember, I think we did some, and they strung out a long list of possible zeros. So, a few other people have come up with rules to shorten the list, to shorten your search for the list. They don't shorten the list, but they shorten the search for the list. One of these is our good old buddy, Rene Descartes. Have we mentioned him before? Okay. If we had in the other classroom a graph board here that had XY graph on it. Anyone know a name for that besides the graph board? It's called a Cartesian graph, named after Rene Descartes. Okay, he came up. He was the first one to basically tie geometry in with algebra. Before that, they thought they were just completely separate fields. He was able to do that, and his board helped a lot. Okay, he also was a great philosopher. Have you ever heard of the phrase, I think, therefore I am? Rene Descartes, okay? Really bright guy. He came up with this rule of signs. And it's a really simple rule, and it really works well. Now, it sounds, okay, the following theorem, Descartes' rule of signs, sheds more light on the number of real zeros of the polynomial. We know how many the max are, how many? N, okay? But we don't know where they live. Descartes' rule of signs helps us along that. sheds more light on the number of real zeros of the polynomial. Now notice this doesn't say anything about the complex with imaginary part zeros, only the real zeros. So, if this is your function, f of x, a sub n, x to the n plus a n minus 1, blah, 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 blah. Okay, there's your polynomial, degree n. Okay, you have polynomial with real coefficients, and now I think they got this correct, but normally this is a sub n is not equal to 0. Otherwise, it wouldn't be an nth degree polynomial. But I believe for Descartes' rule of signs, it's also required that the a sub 0 can't be 0. If the a sub 0 is 0, factor out an x, okay? And then get your polynomial degree n minus 1, where the a sub 0 is. Where now the a sub 1 is your constant. Okay. Now, here's what Descartes' rule of signs says. The number of positive real zeros of f is either equal to the number of variations in signs, look at what that is, of f of x, or less than that number by an even integer, 2, 4, 6, or whatever. It's easier to see than it is to read, okay? But if you're trying to find the number of negative real zeros of f is either equal to the number of variations in signs of f of minus x, not f of x, but f of minus x. Positive here, negative here. Or less than that number by an even integer. Now, can anyone maybe suggest to me why minus an even integer? Remember, this doesn't include the imaginary. In the imaginary roots, if you have imaginary roots, what do they usually show up in? Not apples, but pears. All right, very good. Conjugate pairs, right? Okay, so since they show up in pairs, you could be, if there's a complex root in there, then there'll be a pair of them. So that would be minus 2, minus 4, whatever. So that's why you subtract off the even integer. Now, what is a variation in sign? We talk about them. What is that? That means 2 consecutive coefficients. Now, of course, you have to have it in descending order of the powers, standard form, if 2 consecutive coefficients have opposite signs. Okay? As I said, it's much easier to see than it is to read about. So when using Descartes' rule of signs, a zero of multiplicity k should be counted as k zeros. And we've been doing that. So if you find one and then find that it has another, or maybe even another, each one of those are zeros. Okay? For instance, this polynomial. Okay? Now, it's written in descending order of powers. You're missing the square term. We're not worried about that now, but everything's in order. How many variations in sign do you have? This is a what sign? Plus. There's a variation. There's another. 2 variations in signs. Okay? So that means there's either going to be 2 positive real zeros of this, or subtract 2, 0 positive real zeros. So that either has 2 positive real zeros or no positive real zeros. Never will you be an odd number all. Now, look at this. They somehow factored it, okay? We know how to do that. And because rational zeros test, plus or minus 1, plus or minus 2, over plus or minus 1. So either plus or minus 1, plus or minus 2, there's a plus 1, minus 2. There they are. These two count as the 2 positive zeros. Okay? And because it could be up to 3, you know there's going to be one negative. How do you know there's going to be one negative? If it's not a real zero, if it's complex, it's going to be in pairs. So when you got 2 that were, and that's all you could have, you know you're going to have to look for one x. Okay. Now, if you were doing the rational zeros test, and you did, first thing you do is plug in 1. 1 minus 3 plus 2, that's going to be 0. Hey, we got it. And then what would you do next? Synthetic division, do that 1 into, what would you do it into? 1 what? I can't hear.
-3.
Here we do worry about the missing term for synthetic division. 1, 0, -3, 2. And when you did that, then you come up with a quadratic, factor the quadratic, and you get your other two. Okay? The x equal 1 is a multiplicity of 2. So count it as 2. Would someone bring me a bed? All right. All right. Sorry. So, all it says here is that D'Angelo's here. What we've been waiting for. Okay. And Kiara, is that right? Okay. Now, all we're looking is to determine the possible numbers of both the positive and the negative real zeros. Let's go for positives first. First thing we check, exponents, 3, 2, 1, 0. Okay, they're in the right order. Now they're in the right order, what do we do? Count the partial signs, really simple. Count what? Variations in signs. Is that a variation in sign? Yes, so that's 1. How about here? Yes, there's 2. Yes, there's 3. Or, how many? Subtract 2, and you get, not that hard, 1, okay? Okay, so you either have 3 or 1 variations in sign. Okay, positive. So, let me get my pen back. Oh, man. You either have 3 or 1 positive real roots. Okay, now, remember a real root could be an integer, a fraction, a decimal, or irrational, okay? Plus or minus a square root, So it could be any of those things. So don't think it's all going to be nice whole numbers or things like that. All right, we've determined the possible numbers of positive square roots. We still got to do negative. What do we do next? Got it. Good deal. For those who just come in, we're on page 159, chapter 2, polynomials and rational functions, 2.5 zeros of polynomial functions. And we're doing example 10 now. This says 9, but it's 10. Somehow the book snuck one in that the slideshow didn't pick up. Okay. So how do we determine the number of negative real zeros? What's it we investigate? F of negative x. Now, what's the easy way to determine what f of negative x is? Look at your exponents. If the exponent is odd, change the sign. If the exponent is even, leave it alone. Of course, if there's no exponent, leave it alone. That's a zero exponent. So what would be your first term? Negative 3x cubed. You tell me. Negative 5x squared, leave it alone. Negative 6x, change that one. Negative 4. How many variations in sign? 0. So you have 0 negative real roots. Guess what, folks? Now when you're doing your rational zeros test, forget about the minuses. This doesn't have any minuses. So only use your process. Okay? Make sense? You just got rid of half your work. Kind of. Okay? Descartes' rule of signs can be helpful. All right. Now that's all they're asking for here. All right. Never mind. I know you're in here. There you are. All right. So let me get rid of my chicken scratch so we can read what they do. Anyone need me to leave it a little longer? Everybody got it? Okay. I'm sorry? That's all they were looking for in this one. How many positive real roots? How many possible positive real roots? How many possible negative real roots? That's all it's asking for here. And here they're showing you how to count that. A plus to minus, that's a variation. Minus plus, that's a second variation. Plus to minus, third variation. So you have 3 variations in sign. That means, well, so you have up to 3 possible positive real zeros. Or subtract 2, 1 possible real zero. Okay? Then to do your negatives, you put in a negative x here. Now they're showing you how it happened. I told you the shortcut. Here's why the shortcut works. It's negative x cubed, negative x squared, negative x to the first power. Okay? Well, what's negative x cubed? Negative, and that would be 3, negative 3x cubed. What's negative x squared? That's a positive, so that doesn't change the sign. So the odd exponents change the sign, the even exponents do not. Okay? And then the 4 stays minus 4. So you have no variations in sign. So therefore, from Descartes' rule of sign, the polynomial that has either 3 positive real roots, or subtract 2, 1 positive real root, and no negative real roots. Eliminate the minus from your efforts. Yes.
For the 1 positive real root, why did you subtract 2?
Okay? Because, remember, you know from fundamental theorem of algebra that this has exactly 3 roots. But some of those may be complex, meaning have complex with imaginary parts. Since all your coefficients are integers, or at least all real numbers, therefore the imaginary ones are always going to come in conjugate pairs. So it could be you could have a conjugate pair. So it's either going to be 3 or subtract 2 for the conjugate pair, 1. Okay, that's why you subtract 2.
The next one was 6. You subtract 4 and 2.
Okay, yeah. It would either have 6 real roots, 4 real roots, 2 real roots, or no real roots. Yeah, you keep subtracting 2 till you get something. So yeah, that would have, doesn't tell you everything, but at least it tells you something. Okay? Now, here's another thing I have a feeling it's why you were asking. How do I know that has at least one real root? Not just positive, at least one real root. Leading term, the maximum, the degree of the polynomial is odd. The degree of the polynomial is odd is either like this or like this on the end behavior. You can't get from there to here without crossing zero. Because polynomial functions are always smooth and continuous. Smooth doesn't matter here, but continuous does. You can't get from down here without crossing the x-axis, or from up here to down there. Now, if it was like this, yeah, you could do all sorts of wiggling and squiggling up here and never cross the x-axis. Or you could do it down here and never cross. But if it's odd exponent, you know you're going to have at least one. You don't know if it's positive or negative. This tells you you're going to have at least one positive. But it has no negative real roots because of this. All right, does that make sense? Okay. There is a checkpoint bottom of the page. And if you're having trouble with the checkpoint, go to larsonprecalculus.com and you'll get audio video solutions for that. All right. Here is the graph that we just did. Okay. We didn't do it, but they did. Okay. They found that one positive real root. We would have found that if we'd have looked at it. How do you do your first one? 1, just add your exponents. 3 and 6 is 9. Negative 5 and negative 4 is negative 9. That's 0. There's your 1. X equals 1 is going to be a root. But you don't know if there's going to be any others. But how would you determine that? Through synthetic division with 1 on the inside. 3, negative 5, 6, and negative 4 on the outside, that on the inside. Do your synthetic division. When you get down to a quadratic down here, which you would in one step, because this is cubic, you'll get here, try to factor it. Can't factor it, try to use quadratic formula. You're going to get i's. Guaranteed. Okay? Because this only has that one real root. The other two are complex with imaginary components. Okay. Boy, they just jumped to something else right away. They don't even give you one to practice on. Well, they did that one. Another test for zeros of polynomial function is related to the sign pattern in the last row of your synthetic division array. Okay? So this is a little more subtle, but it pays to pay attention. This test can give you an upper or a lower bound of the real numbers of L, real zeros of L. A real number C is an upper bound. That means that's as high as you can go. It may not be a 0, but if you get, when you try the real number C, upper bound, the real zeros of L, when, okay, here's just a definition. So a real number C is an upper bound for the real zeros of L when no zeros are greater than C. C may not be a 0, but you find none of them greater than C. Similarly, C is a lower bound when there are no real zeros less than C. Okay, I keep doing this. They're really like this. C is an upper bound when there's no real zeros greater than C. In other words, that polynomial is going to go either uphill or downhill and never coming back. Or C is a lower bound when that polynomial is taken off for infinity and never coming back. When there's no zeros, real zeros past that. So, what is the test for that? Here they are. The upper and lower bound rules. The f be the polynomial with real coefficients. Remember, that's a requirement for most of this stuff. They don't have to be integers. They don't even have to be fractions. They could be irrational numbers. That's no problem, as long as they're real. And a positive leading coefficient. That a sub n has to be positive. Suppose that f of x is divided by x minus c using synthetic division. C's out here, and then your coefficients are here. You do the synthetic division, okay? Now, if c is positive, c that you talk about is positive, and when you do the synthetic division, every number in the last row is either positive or zero. In other words, there's no negative down there. Then C is your upper bound. You're not going to find any past that, so quit looking. So if your rational zeros test gave you, in that polynomial, gave you plus or minus blue, but you get it here to this blue, and you do the C into it, and you get all positive there. Throw away those positive ones past that. You know they're not going to work. C is the greatest upper bound. Is an upper bound. Now, if this C happens to be a negative number, which it could be, x minus a minus, that would be x plus something. If that C is negative, and the numbers in that last row are alternately positive and negative, not all negative, but alternating positive and negative, and zero entries can count either as positive or negative, then the C is a lower bound. So if you find that's the case, that quotient line with the remainder, if they're alternating in signs, if this is a negative, then that's as low as you can go. So if this thing's a blah, 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 plus or minus, we'll get the minus here, and you have alternating things here, throw away all the rest of the minuses. No reason to look at them. They're not going to work. So these are 3 tests that give you hints of how to cut down all those possible rational zeros. Okay. They're skipping example 11, so I think I'll go back here and do example 11. Find all the real zeros of this. F of x is equal to 6x cubed minus 4x squared plus 3x minus 2. Okay. How do you begin? We're looking for all the real zeros. How do you begin? What? Still can't hear you. Oh, okay, you can certainly do that. And let's do that. Good idea. And what will that tell you? Number of possible positive real roots. So check your variations and sign. What do we have? 1, 2, 3, or 1. 3 or 1. Positive real zeros. So let's note that. 3 or 1 positive real roots. Or zeros, however you want to call it. Okay? What would we do next? If we're following that train of logic, f of negative x. And that would be, I got her. Okay, good deal. What would be your f of negative x? Negative x, 6x cubed, minus 4x squared, minus 3x. Say again? Minus 2. How many negative real roots do you have? 0 negative real roots. The cart's real assigned, thank you very much. Okay? You know you're going to have at least one positive real zero, but you're not going to have any negatives. Okay? So, what do we do next? Second? Ah, very good. We're going to do our P over Q. Now, we're not ever going to use this again, so I'm going to wipe that out so I don't confuse it. Okay? So we're going to do our P over Q. I'm going to do it up here. P over Q. Now, what in the world is our P? all the possible factors of the last term, 2. But because we already know there's no negative real roots, forget about the plus and minus. We're just doing the pluses. Now, how many possible factors do you have of 2? 1 and 2. Okay? Normally we do plus or minus 1, plus or minus 2. We know we don't have any minuses, so just do pluses. And how about what's the cube? Yes, all the possible factors of 6. And what are they? 1, 2, 3, and 6. My voice funny? Okay, never mind. Okay. Now, normally we put plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. We've eliminated half of them. Just like, thank you, Descartes. Okay. Now, let's list them. Now, the book likes to list them in increasing order. And there's a reason for that. But I like to list the integers first. So I'm going to start with these 2 over 1, which would just be 1 and 2. Now I'll go with the denominator. The first denominator is a 2, so that would be 1 over 2. But do we need to list 2 over 2? 2 over 2 is 1. We already got it. Forget that one. Okay? Then we do the 3's. That would be 1 over 3 and 2 over 3. Okay? Then we do the 1 over 6 and but 2 over 6 is 1/3. We've already listed that one. All right, so now we only have 6 to consider. Okay? All right, already got you here. Okay. All right. All right. Which one you want to start with? Why not 1? That's my favorite. Rather than doing synthetic division, we'll just check 1, right? What you do there is just add your coefficients. Because when you put a 1 in here, that's a 1. A 1 here is a 1. A 1 there is 1. So you just add your coefficients. 6 and 3 are, 4 and 2 are -6. That's not going to add to 0. So we can throw away the 1. It's not 1. Okay. Now the rest of these we're going to do using synthetic division. So let's start 2. That goes outside the house. What goes inside? 6, -4, 3, and -2. Is that enough numbers? Yes, 1 more than your degree. That means you're not missing the term. So, good deal. Then you do what? Bring down, skip a line, draw a line, bring down the 6. Now go to town. 12, 8, 16, 19, 38, 36. Okay? Now, obviously 36 is not 0. For this to be a 0, the remainder would have to be 0. But this tells you something else, but you sort of knew it anyway. All of these are positive. 2 is an upper bound. Well, guess what? 2 is the greatest it could be anyway, right? So that didn't tell you anything new, except 2 isn't 1. All right, that's out of the picture. Okay? So let's go to... I don't care the order of these. Here, I guess it makes sense to go from small to large, even though 1/2 is easier to do than 1/6, I think. But let's start with the smallest, like 1/6. Okay? Now the reason for this is to see if we run into our upper bound earlier. So we'll do a 1/6 here. Okay? And let's go to town with this. What would that give you? 1, -3, -0.5, or 1/2. I'm going to put 1/2. This will be 2.5, 2.5. I'll go back to 0.5. Sorry, I messed up. Okay, and that would be what?
It's not going to end in 2.
I can't hear you.
It's not going to end in 0.
It's not going to end in 0. We know that because it's going to be a fractional form. Because that's not going to be a whole number. Okay, and what's more, you have alternating signs here, so you can keep going. If these were all positives, we can only do the next one to make sure it's positive. But already you got alternating signs, so you know it's not going to be an upper bound. So we'll not do 1/6 anymore. We'll erase this and this. So much easier for me to erase than it is you. Okay, what's the next number you want to use? 1/3. Okay, that's why I left the 1 there. Okay, now let's go to town with this one. That would be a 2, -2, -2/3, right? And then this will be a 3 would be 6/3. No, 9/3. Minus 2/3 would be 7/3. And that's not going to work, right? And you have alternating signs, so let's keep going, okay? Okay, so 1/3 is not going to work. Okay, 1/2 didn't and 1/3 didn't. Oh, I'm sorry, 1/6 didn't. All we got left, oh, we didn't do 1/2, did we? Okay, sorry about that. That's why I like to do them in the order I write them, but I'm trying to show you how the book likes it. So 1/2, what would that be? 3, -1, -1/2. This would be what? 2.5. And then 1/2 of that is not going to be. So that's not going to work. My word. But we still have alternating signs. Okay? So we keep going. Say again? All right. So we only have one thing left. We're hoping it's going to work. Aren't we? Okay. I hope I'm not making any mistakes. I got people checking me, so hopefully I'm not. Okay. The last and only one left is 2/3. What's 2/3 of 6? 4. So that gives you a 0, 0, 3, 2, 0. Ding, ding, ding. We've got a winner. Okay? So we know x equal 2/3 is a 0. And the Cart's rule, okay, two things are happening here. Okay? First, this is a quadratic, so we don't go any further. Okay? So what does that represent? 6x squared plus 3 equals 0. What do you know about that? If you wanted to, you could factor out a 3, and that gives you 2x squared plus 1 equals 0. I can tell you right now, 3 is not 0, right? So that's out of the picture. And what else can this tell you? Can that ever be 0? Not in the real number system. Because when you square a number, any real number is positive. Multiply positive 2 times it, it's positive. Add 1 to it, it's even more positive. So guess what? That's not going to give you any, yes. When you finish it or before the test. Okay? Now we're on 2.5. I don't know how we're doing as far as time because yeah, we got time. Hopefully we'll get into 2.6 today. And then within a day or two, we're going to be through with chapter 2. That's going to be time for the test. So get it in before the test. Preferably before the day before the test, so I can return it to you or let you see your results before the test so you don't make the same mistake twice. So it's up to you. All right. So what we know now, we found one positive real root. The other two from here are going to be complex, so that's why there's only one, not 3. The other thing this tells you is this. Look at your last line down here. They're all positive or 0. What does that mean? The upper bounds test said there are no zeros past 2/3 at work. We already knew they weren't past 2. Now we know they're none past 2/3. Okay? So because all these there are no negatives here. Okay? So upper bounds test tells you don't look any further. Well, that was the last possibility anyway, the way we did it. Now, if we had not done the 2 to begin with, if we had started here and done 1/6, 1/3, 1/2, 2/3, 1, when we got to 2/3, we'd say there aren't any more, so we wouldn't have even messed with 1 and 2. So it would have saved us a little work, but to keep from avoiding fractions, I'll do the integers. Okay. They're just not that hard to do. Okay, but you can do it any way you want to. All right. Now, let's see how they did it. I bet you they did it the other way. Got the same results. Anyone need to up here a little longer? Yes. Okay. 2/3 is the only real root. X equal 2/3. Sorry, I erased it too soon. That was the only real root. Okay. Oh, I'm sorry. That's the other problem. Okay. This one they didn't have. So, here's the other thing that we could have done with that one. And I didn't do it. Sorry about that. Since we had f of x is equal to x minus 2/3, that's a factor. The other factor was 6x squared plus 3. There's the other factor. So you have, this is completely factored in the reals. This is irreducible in the reals. So that's the other thing you get out of that. You get your 1 real 0. You could get the 2 complex if you wanted to, but you could say that's a factor with real numbers. Well, that's a factor with real numbers without having any complex. All right. Any other question? Good question, by the way. I should have kept it up longer. Any? Okay. Now we get to our application. You are designing candle making kits. Each kit contains 25 cubic inches of candle wax and a mold for making a pyramid-shaped candle. Now, a pyramid, let me see if I have a picture. I don't think they do, but just in case. Back inside cover, it doesn't have a pyramid. But let me sort of describe to you what a pyramid would be. These, of course, are triangles. There's a trapezoid. Having a parallelogram, trapezoids, and then the rest of them are circular. Here is a cone. If you had a square base, a rectangular base, some sort of straight-sided figure as a base, but coming to a single point like the cone does, that would be a pyramid. Okay? So, what they say here, you are designing candle each contains and a mold for making pyramid shape. Okay? You want the height of the candle to be 2 inches less than the length of each side of the candle's square base. So finally they got around to telling you the base is a square. Okay, now I don't draw these things well, but I'm going to give it my best shot. Okay? Let's pretend that's a square. Okay? Not a very pretty square, but a square. Now what that means is each side of this base has the same length. Let's just call it S, 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 and S. That makes a square, right? And these are all 90-degree angles. They don't look like it here because I'm drawing three-dimensional. Okay? Okay, each of those are square, or right angles. Now, to be a pyramid, the point up here is exactly, you're coming to now. I should have drawn it better so you could see the other sides. There's a triangular side here, a triangular side here, a triangular side in the back, and a triangular side over here. You can't see it. Okay? So that's a really ugly candle. Okay. Now you're going to make prettier candles than this, right? Okay. Now let's read what it is. Here's the height of the candle. If you come from that vertex down to the base in a perpendicular fashion, that's your height. So we're going to call that H. Now, there's a couple things you need to know here, but let's first do the one they told you about. You want the height of the candle, that's H, to be, that's going to be equal to 2 inches less than the length of each side of the base. Okay? Now, what is the length of each side of the base? S, right? So what does it mean to be 2 inches less than S? S minus 2. Excellent. S minus 2. You start with the length, S, and then take 2 inches off of it. All right, so that's your constraint on your candle making kit. You want the height of the candle to be 2 inches less than the length of each side of the base. That's going to be a really squatty candle, okay? But that's what you want it to be. Now, the question is, what are the dimensions of your candle bowl? What should it be? So you need to know what the S is and what the H is. That's what you're going to be looking for. Now, there's one thing we're missing, and that's the volume for a pyramid. And that's why I pointed you to the back of the book. The volume for a pyramid is just like the volume of a cone. The volume of a pyramid is 1/3 the base times the, hold on. It's terrible getting old and stiff. Okay. This is a cheap flash drive, and anything that touches it pops right out. So I popped it out. Hopefully it'll still work. Okay. So 1/3 the area of the base, that's what capital A is, times the height. Same formula as you use for a cone. Now, you tell me what the area of the base is. S squared, exactly. Length times width, S times S. So this will be 1/3 S squared H. Okay. Now, you got one equation but two unknowns here, S and H. But this equation right here that they gave you tells you what you can do. Instead of H, you write in S minus 2. So this will be 1/3 S squared times S minus 2. Right? Now, you want that to be, in fact it has to be, that volume has to be 25 cubic inches. Because that's how much wax you have. And you want to use it all. You don't want to waste anything, right? Biggest candle you can make with that 25 cubic inches. Okay? Now, what would you suggest we do with that? I'll erase that. Okay. Oh, oops. No, I can't erase that. Okay. Now, let's multiply through and see what we get. In fact, better than that, let's multiply by 3 so we get rid of the denominator. You can tell I really don't care for fractions that much. I know y'all like fractions, but yeah. Okay, so let's multiply both sides by 3. And that gives you, I'm going to also distribute the s squared here. Okay? Get out of there. So that gives me s cubed minus 2s squared, that's from distributing here, equal 75. I'm going to leave off my units. Now, I'm beginning to regret using the symbol s, because it's looking a lot like a 2. But get over it. I mean, a lot like a 5. Okay? Let's get everything to one side, and we have s cubed minus 2s squared minus 75 is equal to 0. Now we have a polynomial equals 0. We can go to town, can't we? What are we going to do first? Okay, someone said factor. How do you factor that? I want to hear this. Oh, yeah, me too. Yeah, okay. Yeah, I wish I knew how to factor it, but I don't. Did I hear someone else say something? Thought I did. Oh, look for sign changes. How many sign changes do we have? 1. That means we only have one positive real root. Now, before we do the second part of the Descartes rule of signs, I wanted to ask you a question. Do any of you think we're going to build a candle with a negative side? No. So guess what? We're not going to look for any negative real roots. Yeah, you might have 2, but who cares? You can't build a candle with that. So we're looking for that one positive real root. We know we got it, so we're going to look for it. Okay, what do we do next? P over Q. That sounds good if that's what you said. Okay. All right. And what's your P? Yeah, of 75. Okay, and what will they be? 1, 2, or you say 3? 3, okay. 5. Say again. 15, excellent. 25 and 75. Did we leave any out? Okay. Now, I'm going to make a suggestion to you. I don't think we're going to have any 75 inch squares. That don't have enough wax for that. So we're not going to use all those, but let's start with the little ones. The first one's really easy to check. Is 1 going to work? No. 1 minus 77, that's not going to work. Okay? So let's throw out the 1. It's gone. Let's try the 3. Okay? So how do we do that? Synthetic division. 3 goes outside the block. What goes inside? 1, negative 2, 0, negative 75. You got to account for every term. We're missing a linear term, so that's a 0 for that one. Okay? We skip a line, draw a line, and do what? Help me. Bring on the 1. That was easy. Next, 3, 1. Get out of there. Okay? 3, 3, and 9. Now, just for fun, we're going to subtract there and get negative 66. Okay? Now, the reason I did that is so you won't think that the upper bound test is working. It's not. You have a minus there, so you can keep going. Obviously, that's not going to work, okay? But we can keep going. So that would be your remainder way out of range. So let's go to the next one, which would be what? We already did 3. Just did 3. 5, okay. All right. If I can get my pen to come up. Okay, 5. Tell me what to do. 5, 3, 15, 15, 75. Ding, ding, ding. We've got a winner. Okay? And frankly, who cares about what's left? There's only one positive real root. We found it. Don't go looking for any others. We don't care about the negatives. We're not going to build a candle with negative sides. So therefore, we have S equal 5. Okay, but that doesn't give us the dimensions of the candle. What are the dimensions of the candle? The base is 5 inches on a side. But what's the height of the candle? Right here, yes. 5 minus 2 equals 3. H is equal to 3 inches. Okay? Like I said, sort of a squatty candle. 5 inches on the side, only 3 inches tall. Okay? But a very pretty pyramid. Okay? You do good work. Anyone need this a little longer? Okay? Let me show you how they do theirs. Let me erase this. All right to erase? Okay? Here's how they do it. The volume of a pyramid, just like we said, 1/3 the base times the height. I did A times the height, but it doesn't matter. B is the base and H is the height. Area of the base is x squared. They use x rather than s. The height is x minus 2 that you get from up here. Okay? So the volume is that's 25. Multiply both sides by 3. You get that. Rewrite it like that. Use possible rational solutions are those. But guess what? Since we're only going to use positives, we can throw out the negatives. So we have exactly like they did. Noticing in this case, it makes sense to test only the positive x's. So they threw out the negatives. They went straight to the 5 because they knew it was going to work. And that gave them their base. The other two solutions are imaginary, can be discarded. We don't care. You can conclude the base of the candle mold should be 5 by 5. The height should be 3 inches. Okay. Here's one additional hint. Remember when it said that the ace of 0 can't be 0? When you do have a function, f of x, that has a common monomial factor, factor it out. Like this one. Remember, I said factor out the x, and then you work with that. You can see x equals 0 is 0 of f, and the remaining zeros can be obtained by analyzing that. So that's their only hint. All right, let me give you, I just lost my, no I didn't, here we go. We'll start next time with vocabulary, okay? So we'll finish up 2.5. But homework exercises here, any of the odds, 9 through 13, they're all at Calc Chat. 9's at Calc View. Either 15 or 17, they're both at Calc Chat. 19 to 27, they're all at Calc Chat. 25's at Calc View. 29 or 31, both at Calc Chat. 29's at Calc View. 33 or 35, both at Calc Chat. 37 or 39, both at Calc Chat. 41 or 40 through 45, all at Calc Chat. 43's at Calc View. 47 or 49, both at Calc Chat. 49's at Calc View. 51 or 53, both at Calc Chat. 55 through 59, all at Calc Chat. 55's at Calc View. 61 to 71, all at Calc Chat. 69's at Calc View. 73 to 77, all at Calc Chat. 79 to 85, all at Calc Chat. 83's at Calc View. 83 to 80 or 89, Calc Chat. 91 or 93, Calc Chat. 95 or 97, Calc Chat. 99 or 101, Calc Chat. Either 103 or Yeah, all 105, both are Calc Chat. True False 107, Calc Chat. You can think about doing 109 through 113. They should be at Calc Chat too. You can think about doing 115. It should be at Calc Chat. 117 would be a pretty interesting one to do, so try to do 117. 119 is an error analysis. I really don't care for it that much, but it is beneficial. Take a look at it. You can think about doing 121 if you'd like. It should be at Calc Chat, or writing an equation 123. So we'll begin next time with the vocabulary and then get started on 2.6. Okay. 2.6 is the last section we're going to do in Chapter 2. So when we finish that, we'll have the test. Hopefully I can talk next week. If anyone hasn't finished Test 1, be good to get that done. Thank you. Thank you. Thank you.
I wanted to ask, I missed my first test. Do you have a makeup day, or do we just need to plan?
Anytime. You can
Your
come in
office
anytime.
hours?
Yeah,
Okay.
anytime during office.
And it was 1.4 through 1.9?
No. Yeah.
Okay,
1.4
okay.
to 1.9.
Thank you.
Yeah.
Steps over. Yeah. 601.